Welcome back to the second part of Trig 5.4 notes. The first part of the notes really dealt with when our equations were exponential equations. Now we're going to take a look at log equations. If you remember, we talked about log equations really had two forms. When you had a log equal to another log, or a log equal to a number. You'll notice in this equation we have 2 times a log being equal to a number. So we want to get our log by itself first. If it's being times by 2, let's divide by 2. So we have log base 4 of x equals to 2.5. Now that we have a log equal to a number, we can write our problem in exponential form. So that's how we're going to solve, right in exponent form. So our base of 4 being raised to our exponent 2.5 should equal our x value. And 4 raised to the 2.5 is going to be 32. We can go back and check it to make sure that this works. If we do a check, we would do 2 times the log of base 4, of 32 equals 5. So we have to figure out what is the log base 4 of 32. So to put this in my calculator, what I really need to do is do log of 32 over log of 4, and then I can go through and times that by 2. So log of 32 divided by log of 4, again that's the change of base theorem, would give me 2.5, and 2 times 2.5 does equal 5, so it checks out. It's going to be important that we check these to make sure that the answers we're getting will work for our problem. So our answer is 32 here. And again, remember when we put this in our calculator, we have to use the change of base formula unless you have a calculator that is set up to plug in a base of 4. And I think some of the TI-84s are set up that way. Okay, so let's apply what we just talked about to the next problem. You have a log being equal to a number, so we want to write in exponential form. So if we write this in exponential form, this time we have to recognize that our base is that imaginary 10 that's there. So 10 raised to the 3/5 power is equal to x plus 5, or x plus 3, sorry. So in our calculator we'll do 10 raised to the 3/5. Again, you want to make sure that that 3/5 is in parentheses. And I get 3.98107. Now that's not all of the number. I'll leave that whole number in my calculator there, and then I'll subtract 3 from that. Now I can round it, and I would get 0.981 if I round to 3 decimal places. If I'm not sure if this is right, we can go through and check it. Take the log of 0.981 plus 3, and when we do that we should get 3/5. Now because this is log base 10 already, I can actually just type that right into my calculator. Log of 0.0981 plus 3, close the parenthesis, and I get 0.491095, which I'm noticing isn't right because I plugged it into the calculator wrong. So let me try that again one more time. Log of 0.981 plus 3 gives me 0.599999, and this is equal to 0.6. So again, the reason that I'm not getting the exact answer is because this is rounded. If I used the exact value of that and added 3, I would have got exactly 0.6. So this answer does check out. Okay, for our next example, now I have a natural log of 2 plus a natural log of x equal to 3. So I don't have one log equal to a number. But what I do know is that I can actually combine or condense these logs by recognizing that I can change addition into multiplication. So that's what I'm going to do first. I'm going to write this as, instead of natural log of 2 plus natural log of x, it'll be the natural log of 2x equals 3. Now I have a log equal to a number, so I write it in exponential form. Now the exponent here on the natural log, not the exponent, I'm sorry, the base on the natural log is e. So we would write it as e raised to the third equals 2x. E raised to the third is just a number. Remember, e is 2.7 ... something. So when I type in my calculator e raised to the third, I get 20.0855, and then I have to end up dividing that by 2. And when I divide that by 2, I end up getting x equal to 10.043 if I round it. So again, if I want to check this out, I can plug it into my calculator. Natural log of 2 plus the natural log of 10.043. Again, you want to make sure when you plug in these natural logs that you're closing the parenthesis before you insert the next one. And I get 3.000002, so again, that's very close to 3 there. Again, not exactly 3 because that's a rounded answer. So, thinking about my next one, it's in log world, and I don't have just a natural log equal to a number, I have 8 times a natural log equal to a number. So I need to get rid of that 8 first by dividing. So the natural log of 3x minus 2 is equal to 3 over 16. Or you could leave it as a decimal. I chose to not write it as a decimal. So now, thinking about this, natural log equal to a number, we've got to write it in exponential form. And remember, with a natural log, the base is e. So we would say e raised to the 3/16, because again, this is my exponent, is equal to 3x minus 2. E raised to the 3/16 is 1.206. And then I'm just writing down a few of those digits. I want to keep this number in my calculator here so that I can actually continue and not round it until the very end. So I'll add 2 to that. Do that up here. So when I add 2, I get 3.206 equals 3x. Now I'll divide by 3, and now I can round that answer. 1.069 equals x. So in my calculator, I'm going to do 8 times the natural log of 3 times 1.069, and then minus 2. And I get 1.505, and it should be 1.5. But again, because that's rounded, it checks out, but it's just not going to be exactly 1.5. Again, very important that we go through and we take the time to check our answers. You'll notice most of the time what we're doing here is we're either isolating the log that we've had, and that's what we did on this example and this example, or we're condensing the log first, and then you'll notice for all 4 of these, we went through and we wrote our problems in exponential form. That's typically the way that you're going to solve log problems, is you're going to isolate the log and then write them in exponential form. Okay, so for this problem here, we've got a log of x plus a log of x minus 3 equals 1. So I've got 2 logs on one side, so first thing I'm going to do is condense. And again, I'm adding 2 logs, so I know that when I condense, I can change it to multiplication. So it will be the 1 log of x times x minus 3. And so really what that is the log of x squared minus 3x is equal to 1. Okay, so if I'm going to solve this now that I have a log equal to a number, I write it in exponential form. Now remember, when we're dealing with the log, it has a base of 10. So we would say then, writing in an exponential form, 10 raised to the first power is what x squared minus 3x is equal to. Well, 10 raised to the first power is just 10. Now I have to figure out how do I solve that. Well, if it was equal to 0, I could factor, so that's what I'm going to do. I'm going to subtract 10, and I'm going to get 0 equals x squared minus 3x minus 10. then I have to ask myself what multiplies to be negative 10 and adds to be negative 3. That's going to be a positive 2 and a negative 5. So x minus 2, no, x plus 2, and x minus 5 will equal 0. So I end up, when I set these equal to 0, getting x equals negative 2 and x equals positive 5, when I add the 5 to move it over. So I have to check to make sure that these work. And again, I wrote a note here, make sure we check for extraneous solutions. And the reason for that is, well, we want to do it all the time, but the reason for that is, notice that I'm taking the log of just an x here. If you happen to get a negative number, for example, like this one, that means when you go to check this in your calculator, you're going to type in the log of negative 2 plus the log of negative 2 minus 3. And you want to make sure that that equals 1. Well, when I type in the log of negative 2, I'm going to get an error right away in my calculator. So because I get an error, I can't take the log of a negative number. I know that this would be an extraneous solution. Let's test it with 5 to make sure that that works. Log of 5 plus log of 5 minus 3, that should equal 1. So in my calculator, I'll type in log of 5, close the parenthesis, plus log of 5 minus 3, close that parenthesis, I get 1. And since 1 equals 1, it checks out. I only have one of the solutions that work here. So be careful when you get a negative number. Sometimes that negative number is not going to work. Now that doesn't mean that it always will be extraneous. It's just for this specific example, because we were taking the natural log of whatever, or the regular log of whatever that answer was, it's going to end up giving us that error because we can't take the log of a negative number. So it's always key to check for extraneous solutions.